The clock ticks slowly aboard a spacecraft bound for Mars. 6 months of isolation, radiation exposure, and the endless void of space ahead. This is the reality of interplanetary travel with current technology. Even with SpaceX's revolutionary Starship and its powerful array of 39 Raptor engines. But what if we could reach the red planet in just 24 hours? It sounds like science fiction, but NASA is turning this dream into reality. Their engineers have been quietly developing a groundbreaking propulsion system that could revolutionize space travel as we know it. This isn't just another incremental improvement in rocket technology. It's a complete paradigm shift that leverages one of the most powerful forces known to science. While Elon Musk and SpaceX have pushed the boundaries of chemical propulsion to their absolute limits with the methane-powered Raptor engines, NASA's new technology promises to be more powerful, more efficient, and dramatically faster than anything we've seen before. Today, we're going to explore this cutting-edge engine that could transform our journey to Mars from a grueling 6-month expedition into a single-day trip. We'll break down the revolutionary science behind it, examine how it outperforms SpaceX's current technology, and reveal why NASA's engineers are so confident this could be the key to making humans a truly multiplanetary species. Hey everyone, welcome back to the Elon Musk 24-hour channel. Let's dive right in. The story of space exploration has always been written in fire and thunder. The roar of chemical rockets pushing against Earth's gravity, carrying humanity's dreams on pillars of flame. For decades, this has been our only path to the stars. SpaceX's Starship, with its cluster of 39 Raptor engines, represents the pinnacle of this technology, a testament to human ingenuity and determination. But even this marvel of engineering faces an unchangeable truth. The physics of chemical propulsion has its limits. Think about this. When the first astronauts embark on their journey to Mars aboard Starship, they'll spend half a year in deep space. That's 180 days of their lives spent in a hostile environment where every minute brings new challenges. Cosmic radiation silently penetrating their shelter. Microgravity slowly weakening their bones. The psychological weight of being further from Earth than any human has ever ventured. And all this time, Mars hangs in their window, tantalizingly out of reach. Sarah Chen, a NASA flight surgeon, knows these risks all too well. Every day in deep space takes a toll on the human body, she explains. 6 months of exposure to cosmic radiation can increase an astronaut's lifetime cancer risk by up to 3%. Their bone density decreases by 1% every month. These are the harsh realities we're fighting against. The race isn't just about reaching Mars, it's about getting there while keeping our astronauts alive and healthy. But NASA's engineers have been working on something revolutionary, something that could change everything about how we travel through space. It's called nuclear thermal propulsion, and it's not just an incremental improvement, it's a complete reimagining of how we power our journey to the stars. At the heart of this technology lies the raw power of nuclear fission. The same process that powers cities on Earth could soon propel us to Mars in a fraction of the time it would take conventional rockets. But this isn't your grandfather's nuclear reactor. The systems being developed today are radically different from anything we've seen before. Dale Thomas, a former associate director at NASA's Marshall Space Flight Center, puts it into perspective. Nuclear propulsion could extract more energy from a given mass of fuel than we ever thought possible with chemical rockets. This isn't just a small improvement. We're talking about an order of magnitude increase in efficiency. The science behind this is fascinating. Picture a uranium-235 atom being struck by a neutron. In an instant, it transforms into uranium-236. But this new isotope is unstable, like a tower of blocks ready to fall. When it splits, it releases an enormous amount of energy, far more than any chemical reaction could ever produce. This is the same process that powers over 400 nuclear reactors worldwide. But NASA's engineers have found a way to harness it for spaceflight. The breakthrough came from an unexpected source. Dr. Elena Rodriguez, a nuclear physicist at Los Alamos National Laboratory, had been studying advanced reactor designs for terrestrial power plants when she noticed something remarkable. The extreme conditions they were creating in their test chambers closely matched what would be needed for space propulsion. It was one of those moments that keeps you awake at night, she recalls. We weren't just looking at a better rocket engine. We were looking at a completely new way to move through space. Traditional nuclear reactors use water as a coolant, but that won't work in space. Instead, these new engines will use hydrogen or ammonia as both coolant and propellant. When these gases pass through the nuclear core, they're heated to temperatures that would melt any conventional rocket engine. The result? Exhaust velocities that leave chemical rockets in the dust. The numbers are staggering. While SpaceX's Raptor engines are incredibly efficient by traditional standards, nuclear thermal propulsion could offer twice the specific impulse, a measure of how efficiently the engine uses propellant. In practical terms, this means cutting the journey time to Mars from 6 months to just a few weeks, or potentially even days. This isn't just theoretical science. Between 1955 and 1973, NASA, General Electric, and Argonne National Laboratories weren't just dreaming about nuclear rockets. They were building and testing them. 20 different engines were developed and ground-tested during this period. The technology worked, but the political and technical challenges of the time proved too great to overcome. James Martinez, one of the original engineers on those early tests, recently shared previously classified footage of their experiments. The power we witnessed was unlike anything we'd seen before, he remembers. The exhaust plume was so hot it appeared blue-white, like a star brought down to Earth. We knew we were onto something revolutionary, but the world wasn't ready for it yet. Now, half a century later, we're ready to try again. But this time, we're smarter about it. The old designs used highly enriched uranium, the kind that raised eyebrows due to weapons proliferation concerns. Today's engineers have found a brilliant workaround: high-assay, low-enriched uranium, or HALEU. It's powerful enough for space propulsion, but unsuitable for weapons, threading the needle between capability and safety. This is where the Draco program comes in, the demonstration rocket for agile cislunar operations. It's a joint venture between NASA and DARPA, with aerospace giant Lockheed Martin partnering with BWX Technologies to develop the reactor design and fuel. Their target? A test launch in 2027 that could change everything we know about space travel. Dr. Michael Chang, lead engineer on the Draco project, describes the moment they first achieved stable plasma containment in their prototype. The entire control room fell silent. We were watching something that could literally rewrite the future of human space exploration. It wasn't just about building a better engine anymore. It was about opening up the entire solar system to human exploration. The engineering challenges are immense. The reactor must maintain its integrity throughout the mission while executing complex maneuvers. The propellant storage systems need to handle extremely cold liquids. The materials used must withstand both the intense heat of nuclear fission and the bitter cold of space. But the potential rewards are even greater. A recent breakthrough in materials science has brought us closer to this goal. Dr. Amanda Foster's team at the Idaho National Laboratory has developed a new composite material that can withstand temperatures up to 5,000 degrees Celsius, hot enough to contain the nuclear reactions needed for propulsion. We've essentially created something that shouldn't be possible, she explains. It's like having a container made of frozen water that can hold liquid steel. Here's what makes this technology so revolutionary. The reactor won't activate until the spacecraft reaches a safe nuclear orbit. This isn't just a safety feature, it's a complete rethinking of how we approach space nuclear power. If something goes wrong during launch, there's no risk of nuclear contamination. The system remains inert until it's safely away from Earth. But the innovation doesn't stop there. Scientists at the Idaho National Laboratory are pushing the boundaries of material science, testing new compounds and structures that could make these engines even more efficient. They're using their transient reactor test facility to validate computational models and evaluate new sensor designs. This isn't just about building a better engine. It's about creating an entirely new paradigm for space travel. The choice of propellant presents its own fascinating challenges. Hydrogen offers the highest performance, providing the greatest specific impulse and velocity change potential. But it's like trying to store a cloud. Its low density means you need enormous tanks to hold enough fuel for a long journey. That's why researchers are also looking at ammonia as an alternative. It's denser and easier to store, though it doesn't provide quite the same performance as hydrogen. A breakthrough came when Dr. Yuki Tanaka, a cryogenics specialist, discovered a way to increase hydrogen storage density by 40% using a revolutionary new compression technique. It was like solving a puzzle that had stumped scientists for decades, she says. Suddenly, the fuel storage problem wasn't insurmountable anymore. But perhaps the most exciting development in this field comes from an unexpected direction. Scientists are working on a concept called the pulse plasma rocket, or PPR. Instead of using steady nuclear heating, this system would create controlled nuclear explosions. Think of it as a controlled fusion reaction rather than a continuous burn. The potential performance is mind-boggling. Up to 100,000 newtons of thrust with a specific impulse of 5,000 seconds. That's far beyond anything currently possible with chemical rockets. Dr. Robert Chen, lead researcher on the PPR project, remembers the first successful plasma pulse test. The energy release was so intense it overloaded our initial sensors. We had to redesign our entire measurement system. That's when we knew we weren't just pushing the envelope. We were creating a new envelope entirely. HAL Industries is leading the charge in this technology, funded through NASA's Innovative Advanced Concepts program. They're not just theorizing, they're actively working on designs that could make this science fiction-like technology a reality. The system would use uranium pellets, superheating them into plasma and expelling them through electromagnetic nozzles at incredible velocities. The implications of this technology extend far beyond just getting to Mars faster. With nuclear propulsion, we could establish permanent human outposts beyond Earth orbit. We could conduct extended operations in deep space. We could even begin to seriously contemplate missions to the outer solar system. The strategic implications for both commercial space operations and national security are enormous. Colonel Maria Sanchez from Space Force's Advanced Propulsion Division puts it in perspective. This isn't just about exploration anymore. It's about ensuring humanity's access to space resources and maintaining peace in an increasingly crowded orbital environment. Nuclear propulsion could give us the ability to respond to any situation anywhere in cislunar space within hours, not days or weeks. But perhaps most importantly, this technology could be the key to protecting human life during deep space missions. By dramatically reducing travel times, we significantly decrease the risks posed by cosmic radiation and microgravity. What once seemed like insurmountable challenges to long-duration spaceflight could become manageable risks. Dr. James Wilson, a veteran astronaut and space medicine specialist, explains the human impact. Every day we can shave off the journey time to Mars is another day our astronauts don't have to spend exposed to cosmic radiation. It's another day their bodies aren't wasting away in microgravity. Nuclear propulsion isn't just about speed, it's about keeping our people alive and healthy as they push the boundaries of human exploration. This is more than just another step forward in space technology. It's a leap into a new era of human space exploration. When we look back at this moment from the surface of Mars, we might well recognize it as the turning point when interplanetary travel became truly practical. The dream of humans becoming a multi-planetary species isn't just closer than ever. It's rapidly becoming inevitable. The collaboration between NASA, DARPA, private industry, and research institutions represents a new model for advancing space technology. It's not just about competition anymore. It's about combining the best minds and resources to solve one of humanity's greatest challenges. Each partner brings unique capabilities and perspectives, creating a synergy that could finally unlock the solar system for human exploration. The future of space travel isn't just about building bigger rockets or more efficient engines. It's about fundamentally rethinking how we move through space. Nuclear thermal propulsion, pulse plasma rockets, and the technologies that will follow them represent a paradigm shift in our approach to space exploration. They offer us not just a way to reach Mars, but a path to the stars themselves. As we stand on the brink of this new era in space exploration, the words of Dr. Elena Rodriguez echo with profound meaning. For the first time in human history, we're not just reaching for the stars, we're building the engines that will take us there. The journey of 1,000 light years begins with a single nuclear pulse. As we look to the stars today, we stand at a pivotal moment in human history. While SpaceX's Starship represents the pinnacle of chemical rocket technology, NASA's nuclear propulsion systems promise to revolutionize our journey to Mars. from 6 months to mere days. This isn't just an improvement in speed, it's a fundamental transformation in how we explore space. The collaboration between NASA, DARPA, and private industry shows us that the next giant leap for mankind won't come from a single company or agency, but from humanity working together toward a common goal. With the Draco program's first test flight scheduled for 2027, we're about to witness the dawn of a new era in space exploration. What are your thoughts on nuclear propulsion technology? Do you think it will complement or compete with SpaceX's Starship? Share your opinions in the comments below. If you want to stay updated on the latest developments in space technology and Elon Musk's ventures, don't forget to hit that subscribe button and join our growing community here at Elon Musk 24 hours. Ring that notification bell to never miss an update about the future of space exploration. This is Elon Musk 24 hours, bringing you tomorrow's technology today. See you in the next video.